Okay, this is the P2 paper from June 2022. It's question number 5, which is trig identities and equations. This is chapter 6. Let's have a look at it and get started then. So we've got, first of all, that 3 tan theta plus 43 is equal to 2 cos theta plus 43, where theta is between 180 and minus 180. So the first thing that I tend to do with these questions is I say, okay, well, if theta is between there, then what I've got, which is theta plus 43, is going to be between 223 there and minus 137 there. Doesn't actually make any difference to the answer at the end, but it's a good habit to get into. Make sure that you're checking your answers between the correct range of values. As I said, we've got 3 tan theta plus 43 is equal to 2 cos theta plus 43. So with this particular one, we need to remember that tan is sine over cos. So if tan is sine over cos, I'm going to get 3 sine theta plus 43 over cos theta plus 43 is equal to 2 cos. And the reason I've done that is I know that the next stage, what I'll do is take that up and multiply. When I take that up and multiply, I'm going to end up with 3 sine theta plus 43 is equal to 2 cos squared theta plus 43. And then if I've got cos squared, I know one of the things about cos squared is that cos squared plus sine squared equals 1. So in other words, cos squared is 1 minus sine squared. And if I get it in terms of sine squareds, I'm going to say now 3 sine theta plus 43 is equal to 2 lots of 1 minus sine squared theta plus 43. Let's just multiply all that out and tidy it up. So I get 3 sine theta plus 43. It's a pain writing that down all the time. Is equal to 2 minus 2 sine squared theta plus 43. I can now get everything onto one side and I've got a quadratic. I'm going to have 2 sine squared theta plus 43 plus 3 sine theta plus 43 minus 2 is equal to 0. So that's just a simple quadratic to be able to solve. I'm not going to, but if you wanted to write it as 2x squared plus 3x minus 2 to then go ahead and solve it, you can do that and then see whether we need to use a quadratic formula or whether we need to factorise using that. It is factorising. It's 2x minus 1 and x plus 2. But as I say, I wouldn't normally do that. By all means do if it's going to mean that you're not going to make a mistake. The most important thing really is that we're getting correct answers. If it takes us a step longer to do it, that's absolutely fine. But as I say, I should hopefully be experienced enough to be able to just do this like this. Sine theta plus 43 minus 2 equals 0. So that's going to give me two different solutions. It's going to give me 2 sine theta, sorry, handwriting, 2 sine theta plus 43 minus 1 equals 0, or sine theta plus 43 minus 2 equals 0. This is going to give me sine theta plus 43 equals 2, which means there's no solutions. Look, I was absolutely ready for that to happen. Good way of them testing all my different bits of knowledge there. So that's not a surprise to me. Sine can never be equal to 2 there. So I'm getting from the other one, sine theta plus 43 is going to equal to a half over here, which means that theta plus 43 is going to be equal to 30 degrees or 150 degrees. Just go back and check your values that we're looking at there. Yeah, no, that's absolutely fine. Yes, and so what, sorry, stumbling over my words here. What I could say is that because it's between plus and minus 180, if we're actually looking at the quadrants when we get our values for sine, all, sine, tan, cos there, we get that sine is positive in those two quadrants. So it's only going to be from 0 to 180 that I'm going to have any of my answers here. Okay, so yeah. In that case, we're going to have, if theta plus 43 equals 30, so theta is going to equal to minus 13 degrees, or theta is equal to 107 degrees. And then when we're looking at those, just check that those two answers do fall back in the range, which they do. And so we've solved that equation. Hopefully that all makes sense.